Hi, my name is Dario Perez. I talk about low noise voltage controlled oscillator using enhanced LC tank. How does an oscillating tank circuit work? Once the energy is supplied to the tank circuit as cycle begins, the capacitor stores energy in the plate configuration. In the circuit, the capacitor plates are connected to the end of the inductor coil. As the current begins to follow out the capacitor, its voltage begin to fall, and in the inductor, a magnetic field builds up around the coil, although the capacitor quickly becomes empty to energy. The current of frequency following in the inductor will have problem due to the effect on the energy in the magnetic field. This current will logging to return current in the capacitor. Allow this time the polarity, the more and less, will be reserved. The cycle is repeated again and again in the period of frequency that is determined by the values of the coil capacitor. Okay, now I talk about get the different equations and solution of the tank circuit using current as a variable. For example, current in versus current out. First, you need to take the equation of the voltage and the capacitor and voltage of the inductor. These two equations is equals. With this, you can replace the difference or the integrate for find the initial current. With this, you can take the voltage inductor or voltage on the capacitor. Okay, now I need to now talk about the how to can resonance frequency of an oscillating tank circuit be calculated. You can match the in place to the inductor and the tank to the capacitor. So we have the equals to equation. For example, the equation of inductor is 2p for frequency that inductor equals 1 over 2p frequency capacitance. We clear the angular frequency and have frequency equals raised squared and over 4p squared c capacitance and inductance. Frequency equals 1 over 2p squared c capacitance and inductance.
Application of a tank circuit. The first and most obvious use will be to be used for radio frequency. This because the circuit is capable of reconstruction sinusoidal signal. However, they cannot reconstruction square waves or complicate audio. If a capacitor parallel to coil is added to a replied circuit, we will generate a tank circuit which will allow us to control the frequency of change in the component switch. DC current could be introduced and the oscillator will transform it into as AC current signal, which is very useful in electronics since many of the components work with alternating current. We use an oscillation tank circuit in the RF transmitter because, as said before, this circuit is capable of reconstruction as sinusoidal signal that could be sent by the radio or television, among others. The variable capacitor is necessary to be able to change the resonance frequency and, in other words, change the radio. We use an oscillation tank circuit for AM transmission because it can be synchronized at any type of frequency as long as we have the corresponding values.